This lesson focuses on greatest common factors and least common multiples. A common factor is a number that is a factor of two or more numbers. The greatest of the common factors of two or more numbers is called the greatest common factor, or the GCF. The least non-zero number that is a multiple of two or more whole numbers is the least common multiple, or the LCM of the numbers. To set up your notes, let's make two columns, one to focus on the GCF and one on the LCM. And we'll break down the vocabulary that we're using so it's easier to understand what other mathematicians are saying to us. So in your left column under GCF, we'll write that the GCF stands for the greatest common factor, and we'll define it by breaking down the words that we use. Greatest means the largest of a set of values, common means the same feature among several numbers, and factor is simply a number that is multiplied by another number. For the LCM, we're talking about the least common multiple, least meaning the smallest, again common meaning the same, and multiple this time is the product, the result of doing the multiplication of whole numbers. So for example, 2 times 3 equals 6. In this case, 2 and 3 are the factors of 6, and 6 is the multiple of 2 and 3. This would be a good time to pause the video to write down your vocabulary, copy these columns down, and once you've completed that, restart the video for the examples. Our first example asks us to find the greatest common factor for 12 and 18. And the tool that we're going to use to do this is called a factor tree. Now a factor tree helps us find the prime factors for a number. So in this case we're starting with 12. 12 is composite, meaning it has factors other than 1 and itself. And so we will start with the smallest of those factors that we can find. Now we're not going to use 1 because 12 divided by 1 leaves us with the 12, and that doesn't help us break it down any. So we'll go to 2 since 12 is even. And 2 is a prime factor, so we'll circle that. And 2 times 6 is 12, so we'll write the 6 here. 6 is composite. It has factors other than 1 in itself, so we'll break it down into its prime factors. It's even, so we have a 2. And 2 times 3 is 6, and 3 is also prime. Now once we've reached the point where we have no more composite numbers to break down, we've completed the factor tree for 12. So now let's take a look at 18. 18 is a composite number. It is even, so let's start with 2. It's prime, so 2 times 9 is 18, and 9 is composite. It breaks down into 3, which is prime, times 3, which is prime. So we've completed the factor tree for 18. So now our job is to look for common factors, the factors that show up on the prime factors that show up on both trees. And when I look, I see a 2 and a 2 on both of the trees, so I'll record that down here. And then I also see a 3 and a 3 on both, so I will record that. Now I know there's a 2 left on 12's factor tree and a 3 on 18's, but since they don't pair up for greatest common factor, we don't need those. So now we're going to take the numbers, the prime factors that showed up on both trees, multiply them together, and we get 6. So this tells you that the greatest common factor for 12 and 18 is 6. Let's try this again with 12 and 66. Now we've already completed the factor tree for 12, so this one will go fairly quickly. We know it's 2 times 6, and 6 is composite, and that breaks into 2 times 3. And now let's do the factor tree for 66. And you might initially think that this is going to be a big factor tree, but once we get started you realize, that sometimes they're smaller than we realize. So 66 is even, so it's divisible by 2. 2 times 33 gives us 66, and 33 is composite, so we have to break it down. 33 is divisible by 3, and 3 times 11 is 33. Well, 11 is prime, so we can circle that. See, that was much easier than we thought it was going to be. Alright, so let's look for prime factors that show up on both trees. We have a 2 and a 2. So that's 1. That's the only pair that I see for 2. So let's move to the 3's. We'll record that. And the 11 doesn't pair up with anything. So we just have 2 times 3, which is 6, and that is the greatest common factor for 12 and 66. All right, it's your turn now. You're going to set up the factor tree for 18 and the factor tree for 30. Break those two numbers down into their prime factors. Look for pairs, numbers that show up on both trees, and then multiply your results. Pause the video as you do this and restart to check your answer. All right, so this is what you should wind up with for the factor trees for 18 and 30. And you see again that 2 shows up on both trees, 3 shows up on both trees, and 2 times 3 is 6. So 6 is the greatest common factor for 18 and 30. Try it one more time with 32 and 48. Pause the video, set up your trees, and then look for common factors on both of those trees. All right. The trees were a little longer than our previous examples, but it's okay. They didn't take that much time. It makes it very easy to see where those factors pair up. We actually had 4 pair of 2's between the factor trees, so we need to multiply those 4 2's. 2 times 2 times 2 times 2, which gives us a product of 16. So 16 is your greatest common factor for 32 and 48. So this would be a good time to make sure you have all of your examples down. If you made any mistakes, that's okay. Correct them and make a note about what your error was so you learn from them. So let's move on and talk about least common multiples. Now in the example that I mentioned earlier in the video, I talked about 2 times 3, and that 6 is the multiple or a multiple of 2 and 3. So now we're looking for those numbers that we get as a result of the multiplication. We have a couple of methods we can use to find least common multiple. In the first example, finding the least common multiple for 2 and 3, we're going to use a number line. So I'm going to put a red X above each non-zero multiple of 2. So I'm going to be very orderly about this. So I'm going to think about what 2 times 1 is. Well, that's 2. And 2 times 2 is 4. And 2 times 3 is 6. And 2 times 4 is 8. And so forth. And I've hit the end of my number line. So now I'm going to go in and look for multiples of 3. And as soon as I see a number that has both a red and a blue X on it, I know that that is a common multiple for 2 and 3. I'm looking for the smallest common multiple. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So I have common multiples at both 12 and 6, but the least of them, the smallest, is 6. So the least common multiple for 2 and 3 would be 6. I can do the same type of thing with lists. I can list out multiples of 2. So I'm going to do this in order. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, times 5 is 10, 2 times 6 is 12, and then I'll do the same thing for 3. 3 times 1, 3 times 2, 3 times 3 is 9, 3 times 4 is 12. And while 6 and 12 show up on both lists, 6 is the smallest of the two, so that is my least common multiple. I'm going to show you how you can do this with factor trees, but I want you to be careful because we use the factor trees with the greatest common factor as well. So in this case we have a problem where we're asked to find the least common multiple of 14 and 21. So I set up a factor tree for 14, so you see 7 times 2, both are prime numbers now, and 21 breaks down into 7 times 3. Well, I'm going to catch that shared or common multiple, or common factor, sorry. So I write my 7 down, but when I'm finding the LCM, I have to include all of the numbers that aren't common as well. So this time I have to write down the 2 and the 3. And when I multiply 7 times 2 times 3, I get 42. So 42 is the least common multiple for 14 and 21. Let's do this with 2 and 6. So if I list my multiples of 2, I have 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Then if I list multiples of 6, I get 6 times 1 is 6, and right away, this one's pretty straightforward, right away 6 shows up on both lists, so 6 would be my least common multiple for 2 and 6. You can find the least common multiple for more than 2 numbers, which is what we're going to do for the next 2 examples. So let's look for the LCM for 4, 5, and 10 this time. So I can list out some of my multiples of 4. 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. Oh, I wrote 50, sorry about that. 20. And then I can list out multiples of 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. Hey, 20 shows up on both lists. And when we look at multiples of 10, we see 10 times 1 and 10 times 2. And as soon as we see a number show up on all 3 lists, we know that that is our least common multiple. It's your turn to take care of 3, 5, and 7. Pause the video and then restart when you're ready to check. Alright, in this case, if you listed out your prime factors, or your multiples for these prime numbers, you probably had to make some pretty long lists. A little hint, when you are looking at 3 prime numbers, you can find the least common multiple by multiplying the 3 of them together. So whether you made a list, whether you used a number line, you should wind up with an LCM of 105. Alright, double check your notes, make sure you don't have any questions. If you do, write them down and bring them to class with you tomorrow.